All right, so going to 10 practice problems now. I think we should be graphing a point slope form of a line, so we'll do that as well. Okay, so linear 1 and linear 2 were the lectures. Now we're just doing the mechanics. All right, write the equation line through 2 points. I did suggest maybe putting your x's -8 and 1. So that's going to become x plus 8. Right, subtract out the first x, minus a minus means x plus 8. And from -8 to 1 is a change of 9. And from 3 to -7 is a change of -10. And if I drop the -8 in, I want a y value of 3. If I drop the -8 in, I'm getting -10/9 times 0. And 0 does not equal 3, but it sure does if I say plus 3 at the end. All right, so there's the first problem. Oh, I trust the science card. This is getting to be a habit. I left it over at the last problem I did 2 minutes ago. Well, tomorrow's Christmas. So this will be the last video I do today. And then I'll go greet Santa. I gotta catch him this year. I'm sure he's coming down the chimney soon, so we'll get this done quickly. All right, so problem number 2, slope intercept form, I assume. So y equals 5/2 x minus 35/2. And I'm going to add the 4 to the other side, and I'll do it in another line of work just to make sure you see what's going on. Minus 35/2. I need to add something divided by 2. I think the number 4 is 8 divided by 2. So y is equal to 5/2 x. Minus 8 is, I believe, minus 27/2. All right, and let's go back to the first problem. I do want you to get in the habit of checking your work. It's not hard to do. We're going to drop a 1 in and a -7 for the y. Oh, that's nice. 1 plus 8 is 9. That cancels. -10 plus 3, -7. I think it's useful for those of you who are starting your algebraic careers to see how numbers work. All right, so let's name 4 points on a line. I gave you this, slightly different this time, slightly different look to it. And that's a product, and you want that product to equal what? If you said 0, you're right. So we start with a 0 and our x is changed by 2. 2, 4, 6, 8, 10, boom. All right, and what goes with a 0 if that's gone? -11. And that means our y's are changing by 3 and they're going up. -8, -5, -2, +1, +4. Let's see if 10-4 really works. 10-4 rubber ducky. My youngest son was born and I called my father. I said 10-4, which way back then was CB talk, and he hung up on me. Thought I was over and out. So let's drop a 10 in. Oh, that's nice. 10's a multiple of 2. 2 goes into 10 5 times. 3 times 5 is 15. What is 15 minus 11? 4. Move on. I'm going to do a quick sketch. Point slope. Well, I know -4, 8. We're just getting practice here. Let's call this -4. Let's call that 8. All right. And I know that I'm going up 2 and over 9. What did you say? You'd rather go over 9 and up 2? Oh, well, we ended up at the same place. So there's that line. Okay. And if you want to label, you can. And, you know, on the side here, you can say, I can see how a -4, 8 works. And I hope you can see over 9 makes that 5. And up 2 makes that 10. Let's see if 5, 10 really works. Geez, those 9s cancel, don't they? 2, 10 minus 8's 2. Oh, it does work. Nice to see that. All right, what the heck did I ask here? Oh, we're solving an equation. Well, in my class, no -9, no -9, just -9 on that side. -10 is 13, so this is 14. Got to get my eraser. Multiply that by 7, which is 98. And divide by -5, but put the negative in the numerator. Okay, let's actually put that number in here. 98, -98 fifths. Oh, I can see a negative times a negative is a positive, so I can get rid of those. I can see the 5's cancel. And I know 7 goes into 98, 14, and 14 plus 9 is 23. Yippee. All right, so what gets rid of multiplication by 7 and 2? Well, I'm sorry, what gets rid of division by 7 and 2? Multiplication by 14. All right, well, 7 goes into 14 twice, so that's -16x. 14 times 3 is 42. 2 goes into 14.7, so minus 35x. Now I wrote the x's this way to say that, you know, it's still means the same thing. You multiply, then divide, or divide, then multiply, divide, then multiply. You have a choice, but we don't have a number to work with, so we just rename it. 14 times 4, 56. Okay, so 14 times 4. In your brain, I hope you're saying 4 times 10, and then 4 times 4. 4 times 10 plus 4 times 4 is how you can do that quickly. Okay, distribute it. All right, we're going to bring the 35 this way, and 35 and 16 are 19 apart. It's going to become positive 19. Subtract 42 from 56, and I think you're 14. So we got 14 over 19 is our x value. Is there a quick and easy way to see that? Not really. These are not parallel, but it's still going to be hard to, I don't know. Let's actually graph this one best I can. So I'm going to call that 3 units. I'm going to go over 7. That to me is 7, down 8, a little bit bigger than that. I think right about there. That's my best guesstimate. Geez. 4 is just a little bit higher than 3. Over 2, down 5. That feels like a down 2 to 5, something like that. Whew. Looks like I got a very small positive x. Oh, that's a small positive x. I'll go with it. 5x minus 7y. Let's get this in standard form. So you're going to fill in the zeros. We want products to equal 0. So if I plug a 0 in there, that means it's minus 27ths, which is near negative 3. We'll call that minus 27ths, 0 comma minus 27ths. Did I think about this before I did it? No, but subtraction means got to be going up. If this gets bigger, that's got to get bigger too in order to maintain that constant. So they're both going up. Okay, so I did that properly. And now I cover that one up with a 0 here, and I get 4. Okay, that's your 3. 4 is probably there. Got the line. All righty. Come on, science card, follow me along here. Parallel and perpendicular. Hey, you might have this down to 10 seconds by now if you saw the pattern. You're looking for the pattern. All right, so perpendicular. Might as well write the perpendicular right now. And let's have it go through. Hi there. Hi there. You say hi. Plug hi in. And I'll tell you you're there. Okay, perpendicular is 4/3. Let's prove it. 4y equals negative 3x. Negative 3x, we don't care about the constant. So x equals minus 3/4 x. That is the parallel rate of change. So y parallel, part is parallel, y equals minus 3/4 x minus high plus there. Okay, so there's our high there. And the negative reciprocal is indeed 4/3, yes. And we've graphed that 3 or 4 times on the earlier ones. So we'll move on. All right, so no user-friendly numbers here, but I did. Let's see if we can get this so that we can see everything. Hang on. Got to pick the card up. Oh, all right. So 2x minus 5y is a linear function that's going down. Oh, no, that's the one that's going up. Excuse me. This gets bigger, that's got to get bigger. Okay, so minus 11/5 is the y-intercept. 11/2 is the x. Okay, 11/2 is about 5, and it is 5.5. Minus 11/5 minus 2 1/5. That's 5.5. I'll bet you that's a little bit higher. Okay. 3/7 is the y-intercept, and 3/4 is the x-intercept. So I got the 3/4 down. 3/7, however, is smaller. So that should be. Why did I put that there? That was this one. 3. Oh yeah, it was positive. Okay, but I think it's probably more in line like this. But whatever, it's going to be a small x. And so let's go find the small x. So I'm saying it's near 1 for x, near -2 for y. Close enough. Let's get those values. Let's multiply this one by -2. Okay, so I got minus 4x plus 10y. Gotta be careful here, minus 22. It's the end of the video. Talking fast, tired. 4x gone, 7y equals 3. So therefore I have 17y is equal to minus, what have I got? Minus 19. Okay, so y is equal to minus 19 over 17. Is that near -2? Yeah, close enough. I know I butchered that over there. So it's a small negative number. I'm going to go with it. Now we're going to get rid of the y's. I got a negative and a positive, so I can multiply by 2 positives here. I'll multiply this one by 7, and I'll multiply this one by 5. Negative 35, positive 35. I don't even have to do that. I'm not gonna. Okay, that's gone. 7 times 2x, 14x equals 77. Ooh. 20x. 15. All right, so that's 87 and 8. Oh, God, gee. 95. I think I'm almost done here. 34. X equals 95. So x equals 95 34ths, which is a little bit bigger than 2. I didn't like my guess at all. Oh, that's bad, but it's certainly positive, certainly in the right realm. So I'll go with that. And I guess in order to actually be certain, I'd have to check these fractions, and God, I don't feel like it. I don't think I left my y value up there. Too bad. We're done. It's Christmas almost. I'm leaving. It's time to go find Santa. Where are you, Santa? There's a nice roof over there. Why don't you land there?